Okay, let's get started. So assignment 3 solutions are up. So I'll talk about that in a second. Apologies for not having assignment 2 graded by now. One of the graders was feeling ill. So half of you have your grade on assignment 2 by now. Half of you don't. So hopefully that'll be fully graded within the next few days, and then I'll put up a distribution and all that good stuff. Same with lab 3. Okay, any questions about assignment 3 solutions? Or assignment 4, or really anything? Yeah. Okay, so let's look at assignment 4. Okay, so what about, which one? Yeah, problem 1, what about it? Okay, so it's mainly this part right here. It says to implement a program that will find a counterexample. So for some n at least 5, but you can pretty much guarantee it's 5 at this point. If there are some integers between 1 and 1,000, so A1 can be some integer between 1 and 1,000, same with A2, same with A3, same with A4, and as well as C, such that, can you find a counterexample such that for that value of n and some of those integers, A1 through A4 and C, such that the sum of the A1 through A4s raised to their power equals C to the n. So it's just the same thing as finding sides for a right triangle like Pythagoras theorem, except now you have 4 things on the left side instead of 2. It's the same idea. And so now all you're really doing is just searching for a possible counterexample. So what is a naive way that I could implement this? Anyone have an idea? Just naively implement it. Here's an idea. So for A1 from 1 to 1,000, so this is not in C++ language. For A2 from 1 to 1,000, and then etc. At some point we're going to have A1, A2, A3, A4, and as well as C from 1 to 1,000. And then we check if A1 to the 5th plus ... plus A4 to the 5th equals C, then prints the counterexample. Okay, just naively implement it. Just try all possibilities, right? And so you can do this. The problem is if you run it on your machine, it'll probably take around a day of it just constantly churning to find even a single counterexample. So what I'm asking you to do is, can you optimize this program? Can you reduce the number of redundant checks that are needed? And there are a lot of redundancies here. So that's what I'm asking you to do. Does that answer your question? Yeah. Okay. And then for the extra credit, it's exactly the same question, but it's 5 and 6 this time, and also print all counterexamples instead of just one. Okay. Let's see. Yeah, as well as like time, how long your program took. There are a number of ways you can do that. You can just time it because even my program, it's not fully optimized, but mostly I get around 30, 36 minutes of computation, so it's not like you have to time really quick or anything. Just give an idea of how long it took. Any other questions about assignment 4? So it should be relatively straightforward, but of course there are many possible ways that you could optimize your program. Any questions about it? Yeah? Is it possible for us to see an example of how to optimize? How to optimize? The biggest one I've bolded for a reason. So this one will give you the most benefit, I think, to the speed of your program. So are there ways, so I'm going to ask you, are there ways that I could optimize my program? I'm not going to touch my program. I'm just going to compile it differently. So is there a way that I can make it faster just by compiling it differently? Has anyone found it? What's that? Yeah, so with the optimization flag. Yeah. So let's look. So C++ compiler optimization. So let's see. We'll see if Stack Overflow knows. Nope. So none of those. Okay, maybe here. Actually, it might be in the GNU options. Okay, so if you just, GCC is basically the compiler that compiles your program into the executable. So I just searched C++ optimization, and this is the page that they have on their compiler. So I would take a look at this. But there are flags that you can set on your compiler to say, yeah, it's okay if my compiler runs for a little longer, but I'm going to say, yeah, I want this program as optimized as you possibly can. Okay, so make any possible optimizations that you can, and that will help you quite considerably. But that will only help you to a point. It can't help you on everything. So it can't help you make a faster algorithm, right? So, for example, if we just did this naive algorithm, the compiler might optimize some of this away to make it faster, but assuming that it doesn't, how many levels deep do I have here? So, well, I have 4 for the A1, A2, A3, A4, as well as another one for C. So how many levels deep is that? 5. So I have 1,000 times 1,000 times 1,000 times 1,000 times 1,000. That's a huge number of cases that I would have to check. So if the compiler can't optimize that away, if it runs 10 times as fast as it did before, it's still going to take a really long time to run. So that's what I'm asking you to do here. Can you think of a way to make this not have any redundant or have fewer redundant checks from here? So I'm not going to answer this one, and I don't want you to answer it, but I want you to think about this. So this is not a solution. I'm just giving you an example. So if I have a solution, a counterexample, where A1, let's just say, is equal to 5, and A2 was equal to 6. So A1's 5, A2 is 6, that's a counterexample. Do I need to check the case where the values are flopped or switched, where A1 is 6 and A2 is 5? So I want you to think about that type of thing. Well, another thing, what if A1, A2, A3, and A4 are all odd? What is A1 to the power 5 plus A2 to the power 5 plus A4 to the power 5? Well, an odd number raised to the 5th power is odd or even? Odd. So an odd number plus an odd number plus an odd number plus an odd number is even. Do I need to check for C's that are odd? Not a rhetorical question. No. So do I need to check for C's that are odd? No, because an odd number raised to really any power is also odd, but the left-hand side is even, so there's no way they could be the same. So thinking about that type of thing versus just trying every possibility, which you can do, that's fine. It's just that it will take a really, really long time to run. So thinking about that type of thing can really help you here. Here, I should have said 5 here, but yeah, so that's what I want you to think about. Any other questions about assignment 4? Any questions about assignment 3 solutions?
Yeah, can you explain to me the IO?
Yeah, so the IO manip, the entire purpose of that header is for printing to 2 decimal places. That's the entire purpose. And you probably should have seen that for assignment 1 for printing to 4 decimal places, but that's where that header comes from. Yeah.
Can you show us quickly how to use that? Because I've been using printf.
You can do printf too. Yeah, so where this is used is if you scroll way down. Yeah. So yeah, it's for set precision. So there's a function in IOManep called set precision, and you can pass in. So 2 is the number of decimal places that I like. In the first assignment, it would be 4. So what you do here is you don't have to save this to a variable and use it. You can just put it right in the cout statement. So here, if I just did, instead of PREC right here, I just put set precision 2, then everything that will appear after that cout statement on the same line will, I believe, will have 2 decimal places. So I just saved it to a variable here so I don't have to type set precision 2, set precision 2, set precision 2 over and over and over and over. I forget what fix does. Does anyone know what fix does? Yeah.
So set precision 2, you will always have 2 decimal points, but you can have more.
Oh, okay. Yeah. See, I'm learning too. So precision is at least 2 decimal places. Fixed makes it 2. Yeah.
Can you switch precision?
I don't know. Try it out. Download the CPP file on the course website. I think you can, but again, just try it out for yourself to be sure. Other questions? Yeah.
For my total, not my secret menu total, I got it to work fine, but do you have any idea why, like when I was getting my total for this certain secret menu items, I was getting something like infinity for the total, but for...
It's a very expensive menu. It's a very expensive menu. Yeah, I'm not sure how that could happen, unless you were deliberately setting it to be infinity directly, but yeah.
It was happening to me because I didn't initialize it. So then when I
Oh, okay.
and change it, it just came out whatever.
Yeah, so you may have to initialize, some variables you have to initialize, some you don't. Other questions? Yeah.
Why do you use auto for your
The set precision thing? Or just in general?
yeah, you use auto.
Yeah, because I don't have to input the type of the thing on the right side. I could just put double in the case of here. It's just so that I get the type always correct and I don't have to retype it. So if I change, like if I change this to be exactly 4 and not like a double type 4, then I don't have to change double to be int.
Oh.
So it does the right thing for me. You had a question? Okay. Yeah.
Then the CO and ST is constant?
Yeah, so because I'm assuming that the menu's not going to change price, so which could be a good assumption or not, but I'm just going to assume that the prices are not going to change, and so therefore I don't want to accidentally change the price at some later point. Other questions? So there was one thing that I put in here, one paragraph about, there's still a lot of redundant code in here. So I'll show you an example. So this is a modified version of a student submission. So I didn't write most of this. Most of this was written by a student, but I changed some things to make it simpler and more maintainable. But it was fully correct before. So here, look at this example. So this whole example right here, the only thing that really changes from here down to, let's say, cheeseburgers, is the text that's right here is going to change to cheeseburgers. So all of this is exactly the same except the variable, right? So the variable changes, but the check is effectively doing the same thing. I'm printing the same thing. I'm doing the same behavior. And then I'm setting a cost accordingly. So what could I do to make this easier for me or more maintainable? Yeah, write a function for it. So that's why we're covering functions now, so that we can actually do this more mechanically, so that I can just call a function right here and say, yeah, the text that you're going to want to print right here is cheeseburgers. The variable that you're going to want to modify is called cheeseburger. And the result you're going to give back, or maybe a variable that you initialized before, is the cost variable here. So instead of having to write effectively the same code over and over and over again, but just with slight modifications, let's just offload it to a function and make the rest of the code much shorter. I would show this to you, but the issue that we have here is that if we made a function, so let's just say if we go back here. So if I made a function like this, so remember last time we made this function called int sum, and then we returned some summation based off this. I'm not going to rewrite the whole thing, but let's just say we have something like this. So let's just say here I want to print out cout. Come on, it's not working with me. Yeah, so if I want to print sum of 10 or for something, or for whatever example. Or maybe I can do this. So if I say int x equals 10, I want to print out the sum of x, then let's just say we do this. So let's say that I'm passing in the integer x that is right here. I set it equal to this variable called sum, and I return the sum. So, of course, this is going to print 10, right? What if I did this? Yeah, go ahead. Right, yeah, so it's gonna pass in 10, that's no issue here. It's gonna add 1 to x, so x is now 11, good. So sum now is going to be 11. Then we return the sum, which is, of course, 11. So we print 11, no issue there. What if I did this? Not have my computer spin. Come on. What if I just print x right after it? What is it going to print? 10. Why? Well, what happened here? So is this x right here that I'm passing in the same as this x, even if they have the same name? Yeah.
No, because it's not the same scope.
The scope actually won't matter in this case, even though it is different scope. You're absolutely right. But what if I change this to n? This shouldn't actually change anything. But think about it for a second. What am I doing here? What am I passing over from x into here? How is n initialized? Yeah.
You're passing the integer that's saved as x, so it's actually not using it.
Right. I'm passing a copy of the value. So I'm not passing in the actual location of x. So I'm not going to, whenever I modify n here, I'm not going to be modifying the original location of x. I'm making new memory to store n, and I'm copying the value of x over to n, which might be useful. I may want to have a completely different piece of memory here. But what if I want to work with the exact same piece of memory that was there? So if I modify n here, I'm also modifying x out here. Why might that be useful? Consider the examples here. So if I make a function here where I pass in a string, which is what I want to print in this part right here, and then the variable that I want to have be stored some value, if I copy the value over, then the variable back in main is not going to get that value. It's going to get the copy is going to get the value that I want, not the original one. And so that's why we need to have this dual way of inputting values into variables. A way of copying a value over, which is useful in some circumstances, but another way that we're going to see soon. So that's why I'm not showing you the example yet, because it's on something that we haven't learned yet. Okay, so last time we were talking about functions. We started functions. So modular programming in general is take this big, long main function and break it up into smaller functions that are more easy to maintain so that we can compartmentalize our thinking. So instead of having to think about how the entire program works, I can focus on a piece at a time. So we covered some things about functions, and then we saw an example. So the main things of a function are the name of the function, whatever it's going to return, if anything. Is it taking any values in, any parameters, and is there anything in the body of the function? So the header here is everything that's not the body of the function. So all four of those things take away the body. So mainly the return type of the function, which is int for main, the name of the function, which is main, and then any parameters that are passed in. Are there any parameters for this declaration of main? No. How can you tell? There's nothing in between the parentheses. Good. And then there's no semicolon here. Yeah.
You just run the code, you have to put it in a function or like you have to declare it.
Good question. So some languages so the question was, do you have to put any code other than the function header inside a function body, or can it live outside the function? And we're going to cover something like that, which are called global variables. So there are, you can declare variables outside of a function, but I think only variables. But yeah, in some languages, you can have the entire program not in a function, like Python. But in some languages, you can't have anything outside a function, like although it's not strictly true, like Java. So some languages you can, some languages you can't. But the vast majority of code has to be in a function. Or in a class, but we haven't covered classes yet. Other questions? Okay, so the return type, you can think of as the thing that's going to be given back to whoever called the function. So remember that sum function that we made last time, and I referenced today. What was the return type of that sum function? It was int. So if I called sum of 10, for example, what type am I expecting to be given back to me? Also an int, right. So the return type will communicate to whoever's programming with your code to say, yeah, you should expect this thing to be given back to you. But of course, some functions don't have a need to return anything. So for example, if you have a menu that you want to print to a user, should the program, if you call this function that prints a menu, should it return anything? It's not really doing any computation other than printing anything. So there's a special type in there explicitly for that purpose, which is called void. So void means I'm not returning anything from this function, and you shouldn't expect anything to be. And here's a really weird thing about C++. For main, you can actually make it void if you wanted to. So there are various incarnations of the main function. Must return int. Oh, okay. Yeah. Why must I return int in this case? Yeah.
Because you're going to return.
Right. Exactly. So I have an explicit return 0 here. What if I did this and the error went away? What is this? If I just delete return 0 and just make it return only. Yeah.
Still going to return 0. Or it's still going to exit 0.
Mostly. So it's not going to return anything, but it's not going to return a value. But remember, return says, I'm going to stop execution immediately. So return always stops execution of the function. But if we happen to have a return something like a 0, it'll give back the 0 as well as to whoever called it. So here, if I called sum of 10, then the return here stops the function execution, but it also gives back the value, sum in this case. So if we have void, every return that we have has to have no value here. We don't have to have a return here, but it's just if we want to stop it, we might as well say return. So the void type, the purpose of void is to say we're not returning anything. Okay? Any questions on void? Okay, so void is mainly for if you want to print something. Oops. Yeah, so one of the issues in C++ is how does scope work for variables in general? Don't worry about like if it's inside an if block or anything. How does it work in general? So if I declare a variable here, where can I use it? From below where it is. The exact same thing happens with function. Yeah, the exact same thing happens with functions. If I declare a function up here and I want to call this function, I have to call it from below the function. But consider this scenario. Suppose I have two functions, one up here, one right here. The bottom one calls the function, the top one, and the top one calls the bottom function. So would that work? Let's see. So change this back. Oops. Let's change this back to int. So what if I had a function like this? So let's just call A, and I have another function. Actually, let's make them void for this example. So let's have a void function, and then B. So B is going to call A directly, and A is going to call B directly. Why is there an error on the first and not the second? Right. So remember, the scoping rules for functions are the same as variables. So if I declare a function up here, I have to call it from either where the function is or below where that function is. Here it says, I have an A function here, and I want to call this function B, but it hasn't been defined yet. It's defined below. So this happens all the time, where we have to have a function call, one calls the other, but one of them has to live before the other. There's no way to have them live at the same place. So that's where something called a prototype is. Maybe it's here. Yeah. So the way to get around this is to actually define the function, but in a sense redefine it. So here what we're going to do is create something called a prototype. So a prototype is everything about a function except the body of the function. So basically just the header of the function. So here, what we're going to do is put the header of the function, but put a semicolon there. And do the same thing for B. And now the error went away. So what this says is, I haven't defined this function precisely yet, but it's going to be defined at some point. So I promise that I'm going to define B at some point, but it's the body of the function is not right here. It's going to be later in the file. So this communicates to say, yeah, we're going to have to look through the program again in the case of this function A right here to look for where the real definition of B actually is. Because before, it didn't see it, right? It didn't see this function B because it hasn't been defined yet. But here with this prototype, they are defined. Both A and B are defined. So if you have functions calling other functions, a prototype is always a good idea. Because now we can just say, yeah, these functions are defined, and then we don't have to worry about which function occurs first or later. That sort of thing. Okay. So, yeah. Yeah, so we kind of went over all of this. When you call a function, it executes the body of the function, yeah. Execution resumes wherever the function was called. So if I call a function right here, it calls this function, it runs through this function up here, and then when this function's done, execution is going to start at the exact same place that it was before, as you might expect. Main's called automatically, and main can call anything. Functions can call other things, as you might expect. So yeah, the function prototypes are just a way of handling, communicating to the compiler, yeah, all these functions are going to be defined, but the body of them hasn't been explicitly defined yet. So the header, remember, is the return type, which in this case is void. The name of the function, which is print heading. Does this function have any parameters to it? No. And how do you know? Because there's nothing in the parentheses. Good. So the prototype is the exact same thing, but with the semicolon at the end to say, I'm declaring this function right here, but I haven't made the body of the function yet. As you might expect, you should put the prototype at the top because you don't want it defined below a function, because then you might create some problems about a function not being defined yet anyway. So then we'll get back into the same issues we had before. So put the prototypes at the top like I did in the example. Yeah. A program must, yeah, so you either have to have the full definition there with the body or the prototype itself. But if you don't have one of them, you may have a problem in that you might not be able to compile the program at all. Yeah. If you use prototypes, you can put them in any order in the file. It doesn't actually matter where. It's just you may potentially cause issues. Actually, this statement, traditionally main is placed first, that's historically not being true anymore. The main's usually at the bottom, or at least that's how I do it. Okay, so now let's get into the real meat of functions, which is how do you get data into a function and how do you get data back out of the function? So remember that sum example that we had, where we had this integer n as the parameter. So if we wanted to call sum of 10, we're passing the data into that function by copying the value over. So if we wanted to call the square root function, for example, first we compute the value a times a plus b times b. So I guess we're doing something with right triangles here. So we compute the value first, so it's going to be some value. Then the square root function on its end is going to get a copy, potentially, of that value that's being passed in. And then the square root function is going to do some work to actually do the computation. And then when it's ready to return the result, it's going to be stored back into C, the variable C over here. So I'm passing the value over to the square root function. It does work, and then it gives me back the value. So the values that are passed in are called arguments. So parameters, arguments, that's the same thing. So I'm passing, how many arguments are being passed into square root in this case? 3? Anyone have a different answer? 2? Anyone have a different answer? 1. So why is it 1? How many parameters? So how do I determine where a parameter ends and starts? Yeah. Right. So parameters, remember, are separated by commas. So how many commas are in here in the square root function call? There are 0. So here, there's actually 1 argument here, even though it looks like 3. So remember, arguments are separated by commas. Yeah. So although arguments and parameters are technically different things, they're effectively going to be the same thing. So I won't distinguish between the difference. But if you want to be like a C++ language lawyer or something, then you should know the difference between those. Okay, yeah. So if we want to have a prototype for a function, we also have to include the parameters that are passed in as well. You could put the variable name here, but you don't actually have to for a prototype. Actually for the main function, but that you shouldn't ever do that. But for a prototype, all you need are the types of the parameters that are passed in. So if there are 3 parameters, for example, int, double, and string, for example, I can just write int, comma, double, comma, string, and then that would be fine. I can put the variables if I want to, but it's not necessary. Okay, so that's that. Of course, functions can have more than 1 parameter, as you might expect, as long as they're separated by commas. One issue that could happen is something like this. So let's say that we have let's int sum again. Let's just say we put a short here. And then we return x, for example. It doesn't actually matter. So what if I wanted to do 1,000 here? what would happen? I'm not going to run it, but what do you think happens? So what happens is a silent conversion from an integer to a short. So the short, I don't think, can handle the value 1,000. It might, but I don't think it can handle the value 1,000. And so then it'll do the, it'll chop off the top bits like we've seen before. So just be careful about silent conversions like this. What is best is to pass in variables such that you are guaranteed the type is exactly the same as the ones specified in the function. So if it's expecting a short, I'm definitely going to pass it a short. It's just here I'm not obeying that rule because I'm passing an int. If I pass a short here, if I say it's a short, maybe it's okay. Let's make it too big. Yeah. So then if I do this, then it's going to actually do the conversion incorrectly for me. It's going to pass in something that I don't actually want it to. So just obey the types and make sure that the types are correct. So the reason a lot of development is currently going on with the C++ language is precisely this. What if you could have a function that says, I can accept anything of any parameter type at all? So instead of saying just short here, you can put any type you want there. For example, you can put auto there. Or I can have any return type I want there. So that's actually something we're going to see later in the class. So how would you be able to handle multiple types? So how many of you have remembered the min function? So like if I say min, and if I want to pass 5 and 10.3. So maybe that doesn't work. Let's do 5 and 10. Yeah, so why does that work? Maybe I can do this. Why does that work too? It's the exact same function. Yeah.
Because they're both the same destination. One is both in and one is both float.
Right. But the thing is, it's the exact same function, but it has different parameters, types being passed in. I don't think it's an overload in this case. Let's actually look to be sure. But we haven't covered overloading yet, so don't worry about that. Okay, yeah, so it's what I expected it to be. So it's actually this thing right here that we haven't covered yet, and we're going to cover later in the semester called a template. So what you might want in your code is something like this, all this code over here, where you can have different behavior depending on what you pass in, depending on the type. So like for example, if you wanted to compute like the average of the passed in values, the behavior might be different for integers and for floats or doubles. What if you pass strings in? What if you wanted to add the two values in? So if you want to add two values, that's straightforward for integers and for floats and doubles. What does adding for strings do? I think I mentioned this once. It's called concatenation. So if I have a string here and if I have a string here, adding them together will glue the pieces together in the order that you add them. So what if you wanted to have the same function handle all of those cases at the exact same time without you having to implement multiple functions? So basically the rest of this class is to try to eliminate code redundancy. So techniques to try to eliminate bloated code like all this here. But we haven't seen templates, so I don't expect you to know it yet. So just be careful about what you're passing in for now at least. Multiple parameters, what you might expect. Parameters are separated by commas, as I've said, and then the values of the variables are being passed into the respective locations. So height is being passed into the first parameter of the function, which happens to be called h here, and weight is being passed to w. Does the parameter here have to be called h? No, could I call it w? And then I call the second one h? That'd be dumb, but could I do it? Yeah, I could do it. So part of the important things of C++ is communicating not only the types of the parameters, but the names of the parameters. So here, by calling this H, that's not necessarily the right name for this. I should call it instead what? What would be a better name for this variable instead of H? How about height? That would it would be better to communicate, yeah, I'm expecting something that involves height here. What if I called it X? That might make sense in some contexts, but not in others. So just be careful about the variable names in the function here, just to make it easier for people to use it. Return, it returns some value, or in the case of void, it doesn't return anything. Yeah, so it halts execution of the program of the function right then and there. Yeah, so it can be as long as so for returning a value, the value type should be the same type as the return type of the function. So if the function says I'm returning an int, you better return an int. So to avoid those silent conversions like I just mentioned. Okay, yeah. If you have a prototype, the return type, of course, must be the same. Yeah. So although this is not strictly necessary, and I've seen examples where it isn't, but the vast majority of the time, if you're going to call a function and it returns something to you, you might as well use the value. Although that's not strictly true. Because you don't technically have to use the value, it's just, it might be more relevant. So if you have a function called isValid here, so maybe we're doing some error handling or bounds checking in this case. So the prototype is just the return type, the name, and the type of the variable being passed in. And then the whole body includes the variable name, if we're going to use it, which we are in this case, and then does some work, and then returns something that's a bool. And then I can use it in the main function, or really anywhere else, by saying if is valid of some variable. And then I can offload the work to that function so that I don't have to do the work in that main function, for example. Okay. So here in the earlier example, I had two different return values, places that I can return things. What you could do is you can do all the work and save the result and then return only at the very end. This is entirely up to you. You don't have to return early on, but it's almost always a better idea if you did. But it might be easier to understand if you return only at the end. Okay, so as I mentioned, an example of this is a menu. You can have a function which doesn't return anything. So what is the return type of a function that doesn't return anything? Void. Yeah, so I can have a void function that just does a whole bunch of statements, and I can just call menu in the main function, for example. And then it'll just print the menu. So here is this slide and the next one are probably the most important slides in the class, in my opinion. So the thing that I was mentioning before about the value being copied over, that's called passing by value. Okay? So passing by value is copy the value of the variable over here and put it into the parameter of the function here. So if I'm calling isValidScore here, so score is already a variable that exists in memory. So then when I'm calling this function, I'm making another int right here in some other location in memory, and I'm copying the value from this guy and moving the value, copying the value over to the other variable. Okay? So they are two independent pieces of memory in this code. So that if I change val in the isValid function, it's not going to affect score at all. Okay? So, and of course that might be useful. Yeah, it cannot access the original argument to the function, But the way that you can change the value of the original parameter is something called reference. So by reference, what we're doing here, and I'll show you how to do that, is we're going to call isValid here on score. And so val here is going to be literally the same location in memory. It's the same integer. Okay, it's not an independent piece of memory. It's the exact same piece of memory. Okay, so if I change val somewhere in this code, I'm also changing score. Okay, so if I change one, I change the other. So now we have the freedom of being able to do that sort of thing. So how do we actually do this? So the way you do it is put an ampersand on the type that's in the function itself. So let's see this in action. So let's say that, yeah, I want to make this, I want to eliminate redundancies here. So what is the difference between this code and then say this one? Well, let's just note the differences. Well, this text changes, right? So from double burgers to cheeseburgers, that changes. The variable changes here too, right? So that changes. And should we have a reference on this thing? Do I want to change that value? No, I don't want to change it because I'm not going to re-access it back in main. So there's no reason to have a reference there. I'm going to pass that one by value. Should I have a reference on cheeseburger? It's a sentence never said before in human history. Should I have a reference on cheeseburger? Am I going to, when I make this function, am I going to re-access it outside of the function? Yes. So I should put a reference on cheeseburger. What about CB cost? Am I going to re-access it outside of the main function? Yes. So let's think, well, what should the return type be? Well, there are many ways that I can implement this. Maybe we can say, oh, I'm going to only have two arguments instead. The string that's being passed in and the reference to the variable that's going to change the value. And I'm going to return the cost here, which I could do. And actually, that's what I'm going to do. So I avoid having three parameters and avoids changing other things, but we won't have to worry about that. So what is the return type that I am expecting here for CB cost? A double. So I should put a double here. So I can call this whatever I want, but let's just call it handle item. So what are the two parameters? Well, I need a string to handle printing that thing for cout. So I need a string item name as whatever I want to call it. And then I need the number of items that I'm going to write to in this function. Remember, C++ can't return multiple things. If I could, then I wouldn't bother with this reference thing, but I need it in this case. So I'm going to make a reference to the item count. So the name here doesn't have to be the same name, but it's the same variable it'll turn out to be. So let's just copy this code in and then change everything as necessary. So here, oops, the item name's going to go here because that's the only thing that changes between all of the items. Oops, well this should be in the, that should be there. I don't know why it wrapped around like that. We're going to see into what variable now? What variable is going to change to have the item count? Item count. So I'm going to see into item count here. So if I call this function now, let's say this. So I'm going to call this function handle item. So here I'm going to call it with doubles. Oops. And then what is the variable that I want to update now to have the number of the items? Well, it's double burger in this case. So I'm going to copy it in here. Well, let's see what happens. I'm not done with the function yet, but we're done with class. So let's see. What's going to happen? Double Double Burger is now a reference here. So now when I cin, I'm going to update the original variable. So now I'm in effect doing the exact same thing I was doing before. So I'll see you all on Wednesday.